Okay, I think we're live now. Hi everyone, and welcome to another ReMeLife community update. As ever, we're going to tell you more of what's happening as we get closer to our impending launches. Obviously, we're keen to keep you up to date with all the news, whether it's good and sometimes tough. But I got to say, at the moment, it's all good. It's all good news. We're getting lots of questions coming at the moment, as you can probably imagine, as our community grows. So it's great today that we have Mike of Convex joining us to answer some of those trickier questions, shall we say. I guess you could call Mike the Vitalik Buterin of the lattice block technology world. So this should be a very interesting conversation. So Mike, welcome to ReMeLife.
Thank you for having me on the show.
Looking forward to this. Been looking forward to it for a long, long time. So before we dive into the nitty gritty of the Convex and ReMeLife relationship, why don't you tell us a bit about yourself, about your past, maybe Ocean Protocol, and why you're doing this? What happened? What happened?
Sure. So I'll tell a little bit of my story. So I mean, I was a self-taught techie. So I started coding back when I was 8 years old on a 8-bit computer. So I've always been evolved in and addicted to tech and sort of software and algorithms and code particularly. I also ended up studying economics. So I've always had an interest both in the business side and the technology side. And for quite a few years, I worked at McKinsey and Company, so advising companies on strategy and on technology and on organization and how to build better business models and how to sort of execute on corporate strategy, and also worked with a few governments in the process and non-profits. So it gave me a sort of very broad background of many different aspects of the world economy and the way that that interacts with our lives. Ultimately, though, I think I prefer actually building things rather than writing PowerPoint slides. So I sort of left the big consulting world and went into sort of independent tech, number of CTO roles, mostly focused around data and AI and open source systems. And I sort of naturally found my way into the sort of crypto world when I was CTO at Ocean Protocol, which was a crypto project building technology for data marketplaces and having the idea of like tradable data assets on the blockchain, which I think was a very interesting idea, although perhaps quite hard to execute. And one of the reasons it was hard to execute is the underlying technology of blockchains really wasn't sufficient to be able to enable the kind of vision and the kind of things that we wanted to do. So after that experience, I ended up going into like research mode, really spending a lot of time looking at the fundamental algorithms of cryptography and decentralized systems, and came up with something very interesting, which is lattice technology, which is the foundation for Convex. So basically, it's a brand new approach to doing decentralized consensus and building distributed systems. And that's kind of been my work for the past 5 years. Has been built. Yeah. So over the last 5 years, I've been building Convex and working on projects related to Convex using lattice technology, and that's included some things in the sort of decentralized finance space, in the payment space, intellectual property space, and in sort of infrastructure space. So for things like file storage. So we have this very cool concept called the lattice file system, which is part of what we're building out as the overall sort of set of, I guess I'd say there's a set of connected components that provide different capabilities.
Well, let's go high level, Mike, if I can interrupt you, just forgive
Yeah,
me. Let's start high level because I'm getting questions of what the hell is a lattice? And secondly, why would you want to switch from, because this is our third switch. We were starting off with Besu. That was our original plan because we knew Ethereum well, we knew some of the high level players there well who were supporting us, people like Heather Flannery and Joe Lubin and so forth. But then we moved from that to looking at Cosmos and then basically sort of dived into Polygon because they were offering us a grant. But those days are slightly gone. So we started looking at the problems, and I guess the Vitalik trilemma is the classic problem, and
yeah.
exploring. Without putting words in your mouth, if you could sort of, at a high level, explain why the world needs Convex, basically, and what its USPs are that make it the kind of the
Sure.
next generation of blockchain, if you
Sure.
like.
And I do want to distinguish. I mean, Convex is not technically a blockchain. And this is very important because the fundamental idea of a blockchain is you have a chain of blocks, and then you're always appending one to the end, which has a hash of the previous block.
Yeah.
And that's what is the fundamental design of a blockchain. And there's many different ways of deciding what that next block is going to be. Yeah, this is the problem of consensus, and different systems have developed all kinds of interesting and complicated ways to decide what that next block is going to be, and most importantly, who gets to create it. Yeah, because someone's got to build that block and add it, and then everyone else has got to agree that that was indeed the right block and the right person had the permissions to add it, or had solved the proof of work problem that enabled them to add it. And that's sort of been the assumption underlying all blockchains. Now, we took a different approach because we realized that this is a fundamental limitation. If you're always in this situation where you have to add one block on top of the previous one, you've always got this problem that in order to continue the blockchain, you're going to have to wait for that previous block to be available. Yeah, and someone else has got to build on top of it because they've got to go and hash it and build the next block using the hash of the previous block. Yeah, and that's a fundamental limitation, and it really limits the scalability and throughput, and most importantly the latency of blockchains, because you've always got this delay while each block is individually getting confirmed one by one. So what Convex does is takes a very different approach. Any peer, any node that's participating in the network can publish a block at any time. Yeah, and the blocks aren't chained together, and this is the important point, so they can publish them simultaneously in parallel. And what Convex does is it sorts these blocks into an ordering, and it's actually the ordering of blocks that the Convex consensus algorithm, which we call it convergent proof of stake, is really about agreeing the ordering of these blocks, not having to individually produce those blocks one by one. Yeah, so many people can publish blocks simultaneously, and this removes a massive bottleneck from blockchain systems, which means that we can effectively just run much faster. If you run Convex locally, it'll take just milliseconds to get a result back and confirm a transaction. Yeah, compared to minutes on many blockchain networks, or sometimes even hours if you're paranoid and if you've got to deal with roll-ups and multiple levels of confirmation. So that's a real superpower of Convex, is this low latency ability to confirm transactions very quickly.
So these issues, these three issues that Vitalik always talks about, and starting with speed, if you like, I mean, traditionally, if that's the right word for blockchain, they try and solve them with sharding and roll-ups and various other strategies, but they cause other impacts. So what you're saying is this is a solution to those that is still, I mean, you can't call it blockchain, but in terms of the breadth of functionality that a blockchain has, such as decentralization, nodes, and many other features and functions, it's all the same. It's just that it's a lattice, not a chain. Is that a fair way of looking at it?
Yeah, it solves the same problems. So, I mean, Convex gives you a virtual machine which is Turing complete and can execute smart contracts. So it can do anything the Ethereum virtual machine can do, and in fact, it can do it a lot faster and in a lot more interesting ways. Which we could get into the techie details of that and why, but it's got all the capabilities of a blockchain and some more. My criticism of the trilemma is that it doesn't actually address the metric that users care about. The metric that users mostly care about is not how many transactions are going through the blockchain as a whole, which is what people usually think about when they talk about scalability. Users care about latency. They care from when they take their action, how quickly do they see a confirmed result? Yeah. And that's not in the classic blockchain trilemma.
Oh, that's interesting.
And I think that's actually an important, a key missing point. Because that's actually the metric that users experience. They don't care whether your network is doing one transaction per second, 1,000 transactions per second, or 1,000,000 transactions per second. They care, does their transaction come back quickly? And in many applications,
does that mean, sorry to interrupt, but does that mean, because this is actually the one reason why I found myself really sort of veering towards Convex, because the dream of ReMeLife is one of our members who's got little knowledge of crypto or blockchain being able to walk into a coffee shop and pay at the point of sale with their cell phone, just by putting it onto a payment mechanism, paying in ReMe, and that's micropayments. And micropayments require, just like credit cards, they require speed. You're not going to stand there with a queue behind you for a minute. So
yeah,
it
exactly.
seems
And so for user experience, you absolutely have to have low latency. And indeed, if you're going to integrate with credit card networks, there'll be very strict SLAs. You have to be able to confirm certain things within 2 seconds.
Yeah,
these kind of things. And with a traditional blockchain, you just couldn't do that, but with Convex you can, and you can give that interactive user experience. So we always talk about user experience. It's one of the most important things in any app. Is how does the user feel when they're going through the app and seeing how it functions and how it responds to their desires. And low latency transactions is the key to making that seamless and making that a compelling user experience.
very interesting. That raises another question that I'm looking at here, which is a big one. For many people, it's the elephant in the room, and that is, well, first of all, you don't use smart contracts with Solidity. It's Lisp, but the main one, I guess, packaged with that is that this is not an ERC20. It's a CAD 20. So therefore, is there compatibility with other people's wallets, ETH wallets, and also with listing? And of course, if that's handled, as I understand it to be, through bridging and so forth, then there's the risk of security issues, because half the hacks in the world seem to happen during that process. So there's a package of questions there that I think sort of fit together, and I'm getting that question a lot. What the hell are you doing leaving Ethereum? Why are you not on Solana?
Well, the hell are these people? Solana's got its own thing as well. Remember, Solana's not an EVM based system. So Solidity, I think, was a first attempt at a smart contract language. It's got a lot of flaws, and the Ethereum virtual machine is not the most efficient in terms of its design or its concepts. And it works. Yeah, you can write things in Solidity, but it's painful, and it's complex, and a lot of people make mistakes, and you can really run into some issues when you try and build more sophisticated things. So the Convex virtual machine is really about bringing a more powerful runtime. And that means it has different constructs. It has better data structures. It has better ways of looking up data. You can write a database system on the CVM very easily, because it's got a lot of these additional indexing capabilities, additional handling of immutable data structures, these kind of things. This is all like deep in the techie level, but the end result is you can build more powerful systems and more powerful smart contracts. And we felt that was worthwhile to have those capabilities. But in order to add these capabilities, we had to build a custom virtual machine that worked in a slightly different way from the EVM, and it's proved to be very powerful. In lab tests, we can get over 1 million transactions per second through the CVM.
That's staggering. A million. Let's focus on that for a second. 1 million transactions a second. I think that's pretty close to Barclaycard, isn't it?
It's a lot faster than Barclaycard. I mean, if you look at the Visa network does a few thousand transactions per second.
Wow.
So if the global payment systems are looking at in the thousands of transactions per second range. Now I'd add the caveat that 1 million transactions per second depends on having enough communication bandwidth between the peers. So that's why we've replicated it in labs with fast local networks, but we haven't necessarily done that in global scale ones where you've got potentially limited internet bandwidth. But even so, the point is, as network bandwidth decreases, we're going to be able to make full use of that. And it's certainly I'm very confident that Convex is the fastest network that maintains a single global state. So without sharding, without doing any of these things where you're basically breaking it up into separate subnetworks. If you want a single global state and you want to execute transactions as fast as is humanly possible, I think the CVM is the best design in the world right now.
Sounds good. And all of that without any burning of Chinese coal, by the sound of it.
So this is another beauty of the consensus algorithm. It doesn't require any wasted work. So there's no proof of work. So it's more like a proof of stake system. You've really got each of the peers has a stake, and consensus is determined effectively by those peers voting. Yeah.
Is that stake, sorry to interrupt, is that stake, so we were looking at proof of authority before, clique protocol, but they're pretty much the same, subject to the fact that those holding a node have to stake in a token. So there's a value to their actual participation as opposed to an authority. But in terms of the methodology, it's pretty much the same thing. Correct me if I'm wrong.
Yeah, it's kind of similar. I'd say the key difference is proof of authority is fundamentally a centralized system. Yeah, you have to nominate who those authorities are going to be, and you have to have some centralized governance system saying, these are the people who we allow in our club, and these people can run a node and no one else can.
Yeah.
So you've fundamentally got a centralized system as soon as you go to proof of authority. And if you're going to go centralized system, then okay, you've lost half of the whole reason of building on a DLT.
Well, that's why we moved away from it. We started with the concept, because we have strong support with charities becoming that sort of board of authoritarian, perhaps a bad choice of words, but authoritarian node holders. But we realized then there's no reason not to open it up more broadly, and therefore proof of stake works.
And then charities might not want to be peer operators. It does require some skills. It's fundamentally complicated, but you still need to run a working server on the internet with the challenges that has. And you need to understand what you're doing to some extent. So it's good to separate the roles. And I think this is very important. The people who are good at running peers should run peers. The people who don't want to run a peer shouldn't have to. So Convex is I think pretty good at separating out that these people who opt in are running the network and securing the network. Everyone else is a client of the network and submitting transactions, executing transactions. They've obviously got their own keys, so their transactions are secure. But they don't have to worry about how the network is actually operated. As long as the peer operators do their job, they don't mind. And this gives flexibility, and it gives us decentralization. Because people can run their own peers, and they can validate their own transactions, and they can say, yes, I can confirm that that everyone else's peer is doing a correct job. If you want to, if you're paranoid. I mean, typically you don't need to do that, but it's always good to have it as an option.
Decentralization is a key for us because we're heading towards being a foundation, and that is the very nature of the proposition. So one of the things that came up and is a concern, clearly, and it's wonderful that we have this partnership with yourselves and that you're supporting the build and of where we're going, and we have a broad runway. As we're telling everyone with regard to our current mission, which is to launch the token both to our team and to our early members, but also on the exchanges, but then to move forward to launching the system totally live, so the ReMeLife community is fully live, but then moving on to the world of DeFi, ultimately NFTs and so forth. Now, we've been looking at Cosmos as being perhaps a effective solution for that, because you're effectively building your own blockchain. And that looked like the easier way to handle all these different elements. Whereas you Convex is a global state where we're sharing a chunk of a blockchain. But as I understand it, that doesn't in any way limit us with the ability to build this breadth of down the runway functionality that I've just outlined. I guess I was looking for confirmation.
I think that's correct.
Not losing anything.
I think it's very important to think about, when you think about this global state, what that doesn't mean is everyone can modify whatever they want. What you're effectively doing is you're building your own little chunk of the global state that you have control over. So your own tokens, your NFTs, any smart contracts, you build under your own control, which becomes part of the global state. And other people can interact with it maybe, but you set the rules and you control that little region of the global state. And that's important, because when you start looking forward, as you say about DeFi, you're actually going to want to use other people's facilities. You're actually going to say, actually, these guys have got smart contracts that we'd quite like to be able to interact with. Let's say there's a loan system, a decentralized credit system. Yeah, and another one of the Convex partner companies is building one of these. Yeah, so you would be able to offer those loans and that decentralized credit service to your own the people in your ecosystem without having
no build costs for adopting the existing smart contracts.
exactly. So you've got these. You get a good DeFi system lets you utilize resources that other people have built. Yeah. And that's digital assets, it's tokens, it's smart contracts, it's financial constructs such as loans. You've got access to all that if you want to. Yeah, because it's decentralized. You can opt in, and you've got your own account, and you've got your own ability to interact with those. So that's the advantage of running on a shared global state. Yeah, that you can do these things. And one of the reasons why we don't like shards, because shards put a barrier in the way of doing this kind of thing. Yeah, we want to have a single global state so that all these interactions are really seamless and can happen instantly, and you can do everything in single atomic transactions.
Does that not introduce vulnerabilities, since we're all part in the same swimming pool?
Well, not really, because every single interaction is cryptographically protected. Yeah, so if you've got your own tokens in your own account, only you can correctly sign a transaction to send those tokens somewhere else.
Okay.
Yeah. Okay. And likewise, if you have your own smart contract, and that smart contract has, let's say, a governance feature, so that you can alter some prices or something like that. Yeah. If you tweak the knobs on a smart contract, you would have the only key which would allow you to utilize those features. Right. Yeah. So you even though it's part of the global state, you are the only people with the key. But you're the only person with the keys. You can decide how you want to utilize those capabilities, and no one else can forge your signature as long as you protected your key correctly, and therefore no one else can actually sneak in and steal those funds or manipulate the smart contract in a way that you don't agree with.
Right. One of the other questions that came in, and I guess again this ties in with Cosmos, which gives you complete control. Gas fees. Now, does that, what you've just said, us having our own chunk, if you like, of the lattice, mean that we can set our own gas fees, or is that set globally?
So the Convex, we call it juice on Convex. So the juice fees are very small transaction fees. So that's set globally, but it's very low. Yeah, and it's kind of so low that you're not really going to notice it. Yeah, unless you do some wacky big computation, but digital asset transfers and these kind of things are very, very tiny transactions. So there's no risk of running up big transaction fees on Convex with the kind of transactions that you're likely to be doing.
Right. So each dApp on the lattice is setting its own fee on top of that, should they decide they want to charge a fee for whatever service they're providing, and that stays within their own chunk and doesn't get shared, as does the juice.
Exactly. So I distinguish it between two things. The network transaction fee is really just to reward the peer operators, the people who are operating the peers around the world.
Right.
Yeah. And that's an incentive for them, and it's an incentive for people to participate in the sort of the decentralized consensus. Yeah, and you want those people doing that job well, so it's worth rewarding them and giving them the right incentive. But on top of that, let's say you have a smart contract, that issues NFTs. You can set your own fees for that. Yeah, and you can set that in whichever token you want. Yeah, so you can use a CAD29 token, and you can say, okay, you're gonna have to pay 5 tokens every time you want to mint a new NFT, and that's completely within the control of whoever's governing those and deploying and governing those smart contracts.
Got it. Okay, that makes sense. Another concern which we've talked about recently and resolved, but I'll voice it here because the question's come in a few times. Oh my God, so many wallets. In other words, we're proud of the ReMeLife wallet. It intends to be the app, if you like, that is the front end of our growing functionality, and will expand into offering DeFi services and so forth. So it's all got to kind of happen there. And I guess that's the key phrase, what we envisage. And I'm looking for you to confirm this. is that the ReMeLife wallet will show what is held in the Convex wallet. It'll show the remis that have been converted from caps that are held in the Convex wallet, but the member will not need to either set it up, that'll happen automatically when they set up the ReMeLife wallet, or engage with it. It's happening in background, as happens in many worlds. So there's no extra added complexity, extra layer of required engagement management for the member.
Yeah, that's correct. I mean, I think that's the best way to build decentralized apps. Yeah, you want one app that presents the right user experience and makes it easy for your users to do what they're trying to do. Whether that's token transactions or whether it's chatting or any other app features that you want to include. You want a good integrated experience, and you don't want people to have to install 3 other pieces of software and go through a whole bunch of complicated steps where if they make a mistake they lose real money. And that's been one of the banes of crypto, is that a lot of the crypto natives are quite comfortable with these tools, and they're happy to run 10 different things and manage their keys across multiple wallets. But for the average user, that's not an acceptable way of doing things. So I think your strategy is exactly right. Do it in an integrated app that presents the experience you want for your users. And one of the things that we've been very focused on is making it really easy for app developers to do that. So we have very, very simple APIs that you just literally need to send some little chunks of JSON data to appear, and it can execute transactions for you. And anything you can do on Convex, you can do through, there's literally 2 APIs. There's an API called Transact, which lets you run a transaction. So you are transferring a token or executing a smart contract, something like that. Any kind of transaction is just one API. And there's another API called Query. So if you want to ask a question of the network, you can just run a query and it'll give you the answer. And those 2 APIs are basically 99% of what everything that an app needs to do whatever it wants to do with Convex, just those 2 things. Now there's some other APIs for more administrative things and looking back at past transactions and stuff like that, but the core is just those two APIs, and they're super easy to integrate. So any JavaScript developer or Python developer or Java developer just needs to know how to make an API call. And we also are building some utility libraries to make it even easier. So you don't even need to do the API call if you don't want. There's a tool that'll build the API call for you. So that's part of what we do at Convex Foundation. Fundamentally, we're a non-profit foundation. We provide tools and technology that make it possible for people to build these kind of solutions hopefully as easy as possible.
That's really interesting. I mean, that's critical to us because, as you know, our core mission is, I guess, all revolving around inclusivity. Our mission is to be able to build interfaces that make it possible for those who would normally not consider crypto, tokens, rewards as being their world, generally the world of crypto cognoscenti, the techies of the world. So we've got to build interfaces that make it really easy for them to be able to benefit from, capitalize on the value of their data, their care actions, and so forth. And so what you're saying, in effect, is that as long as we do our job on the interfaces, on the dApps, then underneath in background, the complexity of what we've been talking about can operate effectively. So that's fundamentally important. And
the user shouldn't need to know about it. I would say the only thing that I guess is still an ongoing issue with these kind of apps is if you are giving users their own keys. So there's 2 ways to build an app. You can build a custodial system where the app publisher holds the keys, presumably in some secure server somewhere on behalf of the users, and then you're more like a centralized system then. But if you go self-custodial and you give the users their own keys, you do have to do a little bit of education, how to back them up, how not to give them to random people on the internet, this kind of thing. So I'd say that's the one thing that there is still a little residual complexity around. You can make it pretty easy, but you can't make it completely disappear. Yeah, because if you're relying on the users to secure their own keys and back up their keys, ultimately they have to do something to achieve that. Yeah,
we've got a bit of special sauce, a few magic ideas on how to engender almost fun in making sure that you retain this key knowledge.
fantastic.
We've got some ideas on that. I mean, obviously, what we're doing to a degree is gamifying many of the elements of care, which is so we're bringing a bit of novelty to it. And I guess on that front, another question for you that we all are inevitably asking is whether there's any downsides to us adopting Convex when it comes to our AI projects. And as you well know, we're building a suite of agentic AI and other AI that support our members. And I mean, I assume that you're fully geared up for the integration and adoption of AI projects.
Yeah, and there's actually another company in the Convex ecosystem building AI infrastructure as we speak. So yeah, we're very much aligned with all of that. We're kind of envisioning a world where AIs start to become economic agents in their own right.
Yeah.
Yeah. And one of the things that an economic agent might do is execute a transaction on Convex. Yeah. So we're making sure that we've got all those capabilities so that they're ready for when that sort of becomes a real thing, and it will be. Yeah, we'll have AI agents managing companies, managing stock portfolios sooner rather than later. Yeah, and we're completely ready for that. Effectively, yeah, we've got infrastructure in place. We've got tools in place and other tools being built. So and in a way that it's not been too hard for us, because the way that an agent would interact with Convex is actually the same as the way that a DApp user would interact with Convex. Yeah, you have some client software and it talks through an API. So from a fundamental Convex infrastructure perspective, there actually isn't really any difference between a human using an app and an AI agent calling the API. From Convex's perspective, it's just another user of the network. Yeah.
Yeah.
And most AI systems will run primarily off-chain. So by off-chain, I mean they're doing their calculations maybe on GPUs or in some data infrastructure that isn't being published to a global state. You don't want it going through a global state, and you don't want to be burning transaction fees running computations like that through a decentralized virtual machine. You want to do that off-chain in your own secure infrastructure, and then maybe just the result goes on chain. Yeah. So if the result is a transaction that sends some tokens, fine, that goes on chain. But the rest of it is in more traditional centralized infrastructure or a separate infrastructure network, that kind of thing.
That's a perfect fit, because our partner apps, we've got quite a few already, but we envisage having many apps within the ReMeLife ecosystem, because of course ReMeLife becomes a marketing entity effectively to promote to their target audience, but it also provides the underlying mechanism for them to reward their users of their apps, to incentivize not only adoption but ongoing usage, which is obviously one of the big problems when it comes to healthcare apps, declining stickiness. So that reward that can be generated by a user for whether it's an AI app or a standard app can be generated alongside the AI architecture and then just transferred down to our ecosystem on Convex. I mean, that's what we've talked about before. That's pretty straightforward. Nothing that's 2 years away from being built and that's going to cause us an issue.
No, not at all. It's very plug and play. Yeah, I mean, we've designed this so that anyone can use Convex pretty much independently of what kind of application or tech stack it is. Yeah, it doesn't matter whether you're using JavaScript or Python or some Java enterprise application. It's all plug and play. They can all talk to Convex through the same API interfaces and through the same transaction model, using the same cryptographic techniques to secure it. I mean, that's the right way to build systems. Yeah, you want to build systems that don't have very strong dependencies on each other, so that you're forced to make certain technology choices just to be compatible with something else that you're using. That's often what adds a lot of complexity to systems, is these uncomfortable choices that you have to make. And we've tried to make sure that we built it as componentized and compartmentalized as possible, so that no one has to bother with any of that complexity. And I think we've done a pretty good job of it.
We'll find out. On that note of complexity, we envisage that what we're calling the Regency at the moment, the ReMeLife agency, will be effectively a DeFi interface whereby once a member holds a certain volume of REMIs, converted from caps or purchased, then they'll be able to convert them if they want to Bitcoin or to ETH. Of course, we'll be incentivizing them to hodl them within the DeFi range of services offered, providing them with benefits to maybe to buy into health plans. There's a whole suite of, in fact, we've got 4 major partners now who are looking to work with us on that. But the point is if I understand it correctly, there's no reason why we can't have a simple interface that's sort of API connected to a place where they can exchange those REMIs that are able to do so to other tokens. Is that doable?
Yeah, and there's multiple ways of doing that. So I mean, there's the classic way of using a crypto exchange, a custodial crypto exchange, and there's obviously many of those around the world. There is the method of using a bridge, token bridge. As part of our work with the EU, we've actually built a new token bridge, which will be called Tok Engine, which will be coming out in the near future, and that lets you bridge tokens between different types of DLTs, and that should be possible to do things like you've just described, payouts in Bitcoin or something like that. There's also some other very interesting mechanisms that we probably won't have time to go into in complete detail, but there's things like hash time link contracts. So you basically make a contract, I'll pay you so much of this token on this other network, providing you pay me this different token on this other network. And the only way to unlock the tokens to receive them on the other end is to provide a cryptographic hash. And the hash means that basically until someone provides the hash, the funds are safe and are reclaimable unless that hash gets provided. Once that hash gets provided, then the pre-image of the hash gets provided, so the secret, then you can unlock both sides. So both sides get their share of the tokens. But if that hash isn't provided, then it just gets returned to the original user. So it's actually an interesting way of transferring assets potentially on different networks securely without anyone having to use a bridge or any kind of centralized authority. So if you're able to use that technique, it's a very powerful one. It's a very useful one.
And a very secure one, absolutely.
It's very secure. I mean, it's got its own interesting complexities, but it is a very good method of doing that, and probably safer than using a custodial solution.
And on that security issue, all we hear about over the last week or two is, of course, the quantum threat. What's your thoughts on that?
I mean, I think this is a long way from being an actual threat. I mean, there's a theoretical threat, but it's like theoretically we can send rockets to different galaxies, but in practice we're not doing it anytime soon. And I think that's kind of my view on the quantum threat at the moment. And there are quantum safe algorithms. And if it becomes clear that quantum technology is suddenly getting to the point where quantum safe algorithms are necessary, we'll just switch to them.
If the AI lets us.
So, but I'm not expecting that to happen anytime soon.
Gotcha.
There'll be people worrying about it for many years, but right now it's not a realistic threat. For example, digital signatures, 256-bit digital signatures with 256-bit keys. The kind of things that get used in blockchains and in Convex. in theory, if you have a big enough computer, you can crack those.
Yeah.
But in practice, it's going to require more computing power than the universe is ever likely to see. So although it's a theoretical threat, it's not actually one that you should ever worry about. And quantum, I think, is still in that space, at least until there's a few more major breakthroughs, and then we start worrying about it. But we'll have a long warning window, I think, before that becomes an issue.
And I think it's true to say that we'll all be in the same boat, whether it's blockchain, crypto, the banks, the governments. I mean, we'll all be we'll all be up the creek without a paddle.
When you see governments and banks re-engineering their system at the cost of billions because this threat starts to become real, I mean, that's kind of the point. You just want to start worrying about it as well. But no one who really understands the state of the technology is really worried about it right now. It's just a threat that's, I think pretty remote.
Okay, the last question, because we're getting close to the hour, and both of us love talking, so try and keep it there. In relation to charities, we've got a number of charity partners, and what they're keen on understanding is, well, our model is that we can have a charity take a node, manage a node, gain a yield by effectively staking, be rewarded, gain ReMis for participation, and use their ReMis to incentivize their audience to buy products in ReMi market. It's a nice circular model that is a win-win-win for everyone, I guess, apart from Amazon. But is there anything that you can see in that model in terms of the benefit that comes to the charities from them being able to effectively leverage their membership to gain a return on their purchase in the audience, and on their ability to gain a yield through the node relationship they have? Is there anything I don't know that I should know?
I mean, it's an interesting question, and I think it could get very complicated, because you're effectively building a tokenomic incentive model to create a circular economy here,
Yes.
with some of that cycling through channels. So you really need to model the whole system and have a view of what flows you expect to see. And putting my sort of game theory hat on, you need to look at the incentives of every person at different possible states of the system. If the system is in this state, what's their incentive? Well, it's to maybe buy some tokens and stake more. In other situations, their incentive might be to sell their stake and cash out or do something else. So you have to think about quite a lot of things to get a good balanced tokenomics system. I think a good tokenomic system is self-balancing. So let's say staking, for example. You want a system where the more people stake, yields go down. Because if lots of people are already staking, you don't really need to attract that many more people in. Whereas if there aren't many people staking, you want the yields to be high so that it's attractive and it brings more people in, because you maybe believe you're understaked at that point. So it's those kind of things that I think are important to think about and design that, maybe jointly with the charities. Say, okay, well, how do you want this to work, and what way do you want to manage your funds? And I'm sure some charities will actually have assets, endowments that they need to manage. And I'm sure at the moment they manage them in a very conventional way, but in the future, well, actually holding a portfolio of stake in ReMis may in fact be a compelling option for them if they see.
Well, that's exactly what we've got on the table right now, because as I'm sure you're well aware, they pay very sizable upfront fees for that asset management upfront, and then the actual returns are not that particularly strong. So we have a very strong offer. But I guess actually really what I meant was, I understand the tokenomics have got to be modeled very carefully. That's why we're working with Tesseract and no doubt others. But I was thinking more in terms of the sort of the technology that's required, the smart contracts, whether there are any elements in that sort of definition of the circular proposition I've defined, whether there are any elements that aren't yet built in Convex that we're going to need.
I mean, I think it's more a case of making just decisions on how you want it to work, to be honest. Okay. So we do have a host of different actors and smart contracts that execute these kind of things, and even more a case of sort of a pick and mix of which things work for your tokenomic model. So, it's the same with any token. You've got to decide some properties of that token that give it, the dynamics and the utility that you want. And I think that will be the same with any charity-based staking. You'd have to set the rules of that, and then we've got the tools to implement whatever rules are ultimately decided for that, and also govern it. I think what governance is often overlooked in these systems, because a lot of the model in blockchain was very much you deploy a smart contract, and once you've done that, it's frozen for eternity and no one can change it, and people have lost a lot of money doing that wrong and making mistakes, or getting hacked and not having a way to recover. And I think we put more of an emphasis on, okay, actually you are going to want some good governance, and you're going to want some ability to modify, let's say, the tokenomics if you find that economic circumstances change, or the priorities of the charities change. You may need to upgrade it, you may need to make some of these modifications. So we do try and build things in a way that gives you that future flexibility as well, so that you're not completely locked in unless you want to be. You can lock it down and say, this is fixed in stone forever, but I think a more mature approach is to allow yourself some flexibility for the future in various different dimensions.
Sounds good. Okay, on that note, and just to end, and I'm well aware that you've been globetrotting, bringing new clients onto Convex. Is it fair to say that it's once we are launched, it's a standalone, self-supporting, self-sustaining system? Just needs devs to maybe go in and tweak and so forth. But if aliens kidnapped you, or you won the lottery, it wouldn't impact on our ability to continue to operate. It's
correct. So, and the Convex network, we've been running it for since last year, and it's had zero downtime, and I've not had to touch it. Wow. It's just purring away in the background, and that's how it should work. The code is all open source, so anyone can go and look at the code. Anyone can fork the code, anyone can suggest improvements, and most importantly, anyone can run their own peer using that code. Right. So me disappearing, it might hurt the pace of future development, but it would not stop anyone from continuing to operate on the Convex network.
Perfect. Well, listen, I've got to say that was absolutely fascinating, really enjoyable, and confirmation of what we are very much looking forward to do. And it's all happening fast. We're working together on this now. What can I say? Thank you for that. Unless you've got any questions, I'm sure there'll be other questions that come in. Maybe we'll get you back on if you're up for it.
Just wanted to say thank you, and I'm very much looking forward to seeing it all come together.
Thanks, Mike. And to all the community members, keep your questions coming in, and just don't forget, spread the word. ReMeLife and Lumi are here on the horizon. See you soon. Thank you.
Take care.